discussing the viva questions and answers on the topic elasticity. Before moving ahead with the video, I request you to subscribe to the channel. Now let's get started. First question will be asked, define elasticity. So in this question you are supposed to say the property by virtue of which the material regains its original dimension after removal of deforming forces is called elasticity. For instance, whenever you are stretching an elastic rubber band, you are applying force and that's why the length is increased. But whenever you are removing those forces, it gets back to its original dimension. So this can be given as the example of elasticity if in case they ask you. Then the next question is define plasticity. So over here, plasticity is the property by virtue of which the material undergoes permanent deformation even after removal of deforming forces. For example, you are hitting one cardboard and after hitting you realize that okay, you have caused permanent deformation to this cardboard, means it will not get back to its original dimension just because you have stopped hitting it now. So over here plastic deformation has occurred, permanent deformation has occurred. So this is called as plasticity. Next can be a simple question like define deformation. So it's basically a change in size, shape or both of a body arising due to external force. And you can also say this, that deformation is directly proportional to the deforming forces. Next question, define stress. It is the internal elastic restoring force per unit cross-sectional area. Or you can define it like this, it is the applied force per unit cross-sectional area of the body. Stress is equal to elastic restoring force per unit area. Next question can be related to strain. They will directly ask you what do you mean by strain or define strain. So the answer will be, strain is defined as the change in dimensions per unit original dimensions, and because it is the ratio of the similar quantities, so it is a dimensionless property. Mention the different types of stress. We have three types of stress: longitudinal stress, also known as tensile stress, then we have volume stress and shearing stress. Next question, mention the different types of strains. Again we have three types: longitudinal strain, also known as tensile strain, volume strain and shearing strain. Then you can be asked to define longitudinal strain or tensile strain. Your answer should be, change in length upon original length is termed as longitudinal strain. Similarly, it goes with volume strain like this, change in volume per original volume is your volume strain. And for shearing strain, the formula will be relative displacement of any layer upon its distance from the fixed layer. Now coming to the very important question of elasticity, that is Hooke's law. Majority of the time you will find the examiner asking this question, explain Hooke's law, what do you mean by Hooke's law, what is the formula of Hooke's law, or where is it used. So you will say, the statement goes like this, within elastic limit the stress is directly proportional to strain, and Hooke's law basically describes the relationship between stress and strain. So stress upon strain will be equal to constant, that is our modulus of elasticity. It basically says that stress is directly proportional to strain, and whenever you will remove the proportionality sign, you will have stress upon strain to be equal to constant. And it explains the linear dependence of displacement on stretching. This law is very useful to ensure that components can withstand at the calculated level of force. And this is the graph which is used to explain Hooke's law. Okay, next you need to remember this. Young's modulus is termed as the elasticity of length, whereas bulk modulus is termed as elasticity of volume. Next question can be, there are how many types of elastic constants? So we have three types of elastic constants: Young's modulus, bulk modulus and modulus of rigidity. Now there is a very high possibility that the examiner may want to know that what exactly do you mean by young modulus, what exactly do you mean by bulk modulus, and what exactly do you mean by modulus of rigidity. They basically wants to test the knowledge of the student. So for that, first question is, what is Young's modulus, or explain Young's modulus. The answer will be, Young's modulus represented by the letter Y is equal to the tensile stress upon the tensile strain. Formula for Young's modulus goes like this: Y is equal to mgl upon pi r square L. This can also be written as FL upon AL. Now Young's modulus describes the tensile elasticity along a line when opposing forces are applied. Young's modulus for materials with strong interatomic bonds is very high, and Young's modulus measures the resistance of an elastic solid to elongation. Just remember 2 or 3 important points. For example, what do you mean by Young modulus and the formula of it, and that's more than enough for the viva. They don't even expect you to continuously say answers for 2 to 3 minutes. They expect short answers only, short and precise answers only. Okay, now moving ahead with the next elastic constant, that is bulk modulus. So bulk modulus is represented by the letter K, and this is the ratio of volume stress and volume strain. K is equal to VdP upon dV. It is the property of solid, liquids and gases, and bulk modulus is the change in volume of a body due to applied deforming forces. SI unit will be Newton per meter square. Next is modulus of rigidity. Modulus of rigidity is represented by the letter eta, and this is equal to shearing stress upon shearing strain. Eta is equal to F upon A theta. Modulus of rigidity measures resistance offered by solid when an attempt is made to change its shape, that is motion of planes of solids sliding past each other. Next question can be related to Poisson's ratio. So in this you are supposed to answer that Poisson's ratio measures the deformation in the material in direction perpendicular to the direction of the force applied. It is given as lateral strain is directly proportional to longitudinal strain. Whenever you will remove the proportionality sign, you will add one constant. So lateral strain is equal to sigma times longitudinal strain. Now sigma is equal to lateral strain upon longitudinal strain, and this sigma is my Poisson's ratio. It is a unitless and dimensionless quantity. Next, what do you mean by strain energy? So strain energy is defined as the electric potential energy gained by a wire during elongation by stretching force. Strain energy is given as half into load into extension. What is meant by buckling? So buckling is the sudden change in shape of a material which is under load. Then few things that you need to remember is work done is equal to half into load into extension, and we have the compressibility to be equal to 1 upon bulk modulus. And here is the table which shows the breaking stress value of different materials. That's it for this video. I hope it helps you in scoring good in your viva examination. Thank you so much for watching till the end, and don't forget to subscribe to Solely Science. Thank you.